It's really great to be here, and I'm looking forward to this course. It's actually based on some time I spent working with Jessica Nash at the Molecular Sciences Software Institute, which is based on a number of campuses, but the headquarters is at Virginia Tech. And before we get started today, I have a few notes here for myself to remind you. One is that as I've been going through setup with a number of people, I have found that if you have lots of other applications open and lots of tabs open on your browser, that could slow things down or create problems for you. So I would encourage you at this point to close any applications you're not going to use this afternoon. Maybe even turn off your cell phone. I'm doing the same thing. And also, if you have 20 tabs open or whatever in Firefox or whatever browser you're using, I'd encourage you to limit that number of tabs to just the tabs you're using for today's workshop. I think you'll find it works much better. I do want to thank, we have Jessica Nash is my co-presenter, so she and I will be alternating the presentations and leading the hands-on learning activities that we're going to be doing today. We also have four of our friends are helping as support people, and they're listed under the participants as TAs and co-hosts: Joey Lubin, Julia Kepi, Samuel Ellis, and Charlie Weiss. And they're all available to help. If you have what seems like a simple problem, then send a text to one of those four, and they'll get back to you quickly. If the problem is deeper than that, we do have breakout rooms set up. And so if, for example, Joey Lubin says, "Why don't you meet me in my breakout room?" If you go to the breakout rooms icons on the bottom of the page, one of those breakout rooms is named Joseph Lubin. So you just need to go to that room, and you can join him. Okay. Looking at, one other thing I wanted to mention is that we do have an attendance survey that we're asking people to complete, and many of you have already done this, but just in case, I'm going to put the link in the window here. So that is our attendance survey. It should only take a couple minutes to fill out. There will also be an exit survey at the end, which will take about 5 minutes, and we'll provide a link for that as well. And my other notes here say to slow down, speak clearly, and turn off my other applications. So I'm going to try to do that. And now I'm going to begin. Actually, I'm going to turn it over to Jessica for a minute, and then it'll come back to me. Jessica.
Hi. So hi, everyone. My name is Jessica Nash. I work as a scientific software developer and the education lead at an institute called the Molecular Sciences Software Institute. And so we focus on improving software in the computational molecular sciences. Part of our program is doing workshops like these. So we train people on how to use Python so that they can use, use programming in their research or in their classes. So thanks for coming today. I want to, again, emphasize the importance of this attendance survey that Paul mentioned. If you like, it's very, very important for us to have attendance records for these types of workshops. So if you like things like free workshops, please fill out the attendance form for us. And then Paul, was there anything else you wanted me to kind of say?
Not at this point.
Okay.
Jessica will be leading the second session. So the first session is called Introduction, and let's move there right now. So I'm going to share my screen. And all right. So as we're getting started here, one of the things I want to say is, first of all, you may be coming to this workshop saying, well, I really feel like a novice. Okay, that's great. The purpose of this workshop is to introduce you to Python and to using it in your work with the hope that you'll be able to look at what you've done today and think of ways that you can actually start writing your own code that will help you do your own research, do your own analysis, do your own teaching. Rather than hoping that somebody has a software package out there that you can use, that there's a function in Excel that will do what you want, for example. Okay, you can do everything you need in Python. Well, maybe not everything, but a lot of things that will help with your data analysis and your research. Second thing is that I know that there are at least 2 people in this room that are much more expert at Python than I am, and I'm hoping that if I say something that's a mistake, 3 people. Now I think of it, if I make a mistake, please slow me down, interrupt me, and say, no, actually, this is the way it's supposed to work. And one reason I mention that is because in the world of science, we all like to be experts. We like to be seen as experts. I'm going to encourage you to try to be seen and feel like a learner in this setting, because I very much do. And so with that, we're going to get started with this introduction. And I believe you're able to see my screen. And so in the introduction, we're going to look at the basic syntax of Python. Syntax is like, Jessica, raised a hand?
Yes, I
Okay.
did. I'm sorry, Paul. Could you start by showing how to get to this notebook?
Aha, yes, I can. All right, so if you're in Chem Compute, the Chem Compute setting, then you should, and everything was properly installed, you should have a desktop that looks like this. You click on the iqb.get folder, and it'll take you to this, this folder, which contains the 4 notebooks we're going to be working on. These are starter notebooks: file parsing, introduction, NGL view, and processing multiple files. There's also a folder that contains 10 PDB files that we will be working with today, and some other license and a README document. So if you're in Chem Compute, that's what you should see. If you're using Anaconda, I don't have that up on my computer right now, but hopefully you've got Jupyter Notebook started in Anaconda, and these files were available in a zip file. If you don't have that zip file, I'm trying to think if I can find it quickly and put it in the chat window. I can. I'm going to put it in the chat window right now. Whoops, need to send it to everybody, not just one person. So that zip file in the chat window contains the same exact materials. So you'll just need, if you're using Anaconda, you'll just need to put that, expand that zip file in a folder that you can find from Jupyter Notebook. So typically put it on your desktop and you'll be able to find it there.
Right. And Paul, if we could, since people are following along, maybe we could do a status check here to make sure that everyone is able to open Chem Compute and find this file.
That's a good idea. That's a good idea.
So maybe we could do, so for our workshops, we typically use this system where we get feedback from you using the Zoom. And so if you're looking at, it's okay if you share your screen, Paul.
No, you keep talking. I'll share when it's my time.
Okay. We use the reactions in Zoom. So if you mouse over like your Zoom window where you'll see me talking right now, you should see a button on the bottom that says reactions. And sometimes we'll want to check how you're doing. I see that someone has found the thumbs up. So if we want to make sure that everyone is on the same page, we'll ask you to use one of these reactions. I really like the green check mark for yes. So if you are on Chem Compute and you're able to open your notebook, that is that introduction notebook, can you use that green check mark? If you're not able to find it, one thing that you can do is you can use the red X for no, and one of the TAs here will message you to help you figure out how to get that set up so that you can follow along. And you can put up a red X anytime and a TA will message you on the Zoom chat. So if you put up that red X, make sure that you're watching for someone to message you or message one of the TAs. So that's good. I'm seeing a lot of green check marks, which means a lot of people have that set up.
Right, and there's a few red X's, and the TAs will be visiting you. Okay, should we do the same thing, Jessica, with the people in Anaconda?
Yes. So if you're an Anaconda, also use your green check mark if you're ready to continue. If you're in Anaconda and you have the red and you need help, put up that red X and then let a TA know that you are using Anaconda so that we can help you with that. But hopefully most of us are on Kim Compute. It makes things a little bit easier.
Right. All right, I see mostly the green check marks. I'm grateful that there are check marks and X's because the red and the green look just the same to me. So, all right, so I'm going to go back to sharing my screen. And get the right file up. All right, so we're going to get started now. And I believe the check marks will fade in just a couple minutes, but if they don't, you may have to go in and turn them off, because we will come back to the check marks in the future as we try to run some things to see if you're able to get things to work. So the basic syntax of Python, it's like the grammar. It's the format you have to use, and it is a computer language, and so there's very exact rules about how you state things and the way you use certain punctuation, and we will emphasize this as we go. Now, just to get started, I've got a section here. I'd like you to try something using what we call markdown language. If you look at my screen, you can see that I've got a window, or toward the top of my browser, I have a drop-down box where I can choose either code, markdown, raw, NB, convert, or heading. And so what I'm going to do is I want this IQB crash course, Python scripting in BMB. What we're going to do is we're going to go to the top of the page here. And I'm just going to double click on this window and in erase introduction. And notice that this is a markdown cell. Okay, so if I go in here and I type a £, put in a space and say IQB crash course Python scripting in BMB, and then I'm going to put a little bit more information on there. This is the introduction. And oh, one thing I didn't say, this is a live coding workshop. So while we are coding in our windows, we want you to code as well. And we're not bound by the time. We have a rough time frame we want to work with, but mostly we want to get you in here and get you comfortable with Python. So I typed in introduction, and then I'll type in just a couple comments. So this lesson covers some Python basics like creating variables, loops, and logic. And then to execute a cell in a Jupyter notebook, you hit Shift Return or Shift Enter. And so if you did this in Markdown, you should see something that looks like this now. And I'm actually going to ask for the green checks to let me know if people were able to get this to work. Okay, I'm seeing, I realize that not everybody will be doing the checks, but I'm seeing a fair number of check marks, which is very encouraging. All right, and so continuing to move down. We're going to start off with learning about variables. So if I go into this cell, and you should be your notebook should look the same as the notebook that you're looking at here. I'm just going into this cell. I'm going to type in 3 plus 7. If I hit Shift Enter, it does the math. So Jupyter notebooks can act as a calculator for you, but that's not really terribly valuable for most simple calculations. But what we really need to do is we need to actually do something. We need to assign a calculation or something to a variable. And so I just created this, I just changed this cell to a markdown cell. And I'm just going to write this generic format variable name. So variable name, it can't have spaces in it, equals variable value. Okay. And so that's just a standard way that you could do this. And so what we can do is we can create a variable name and then put an equal sign and then do some calculation and feed that calculation into the variable. And so what I'm going to do here is, I wanted to point out also, when I execute a cell in a Jupyter Notebook, notice on the left-hand side here, it says IN, and then there's a 1 in square brackets. That 1 means that the cell was executed. And if it's an involved calculation, sometimes it takes a while to run. There'll be an asterisk that appears there. But then when it works, it will run. Also, if there's an error, we'll give an error message. We'll see examples of that as we get through here. Some of them we've designed into the workshop, but I probably will make some errors it'll spit out anyway. So what we're going to do in the next cell is a calculation of a Michaelis from the Michaelis-Menten equation. So on this line, I'm putting a pound sign. And in Python, when you put a pound sign in, that means it's a comment. That means that the Python compiler is going to ignore that. Okay? So I'm just going to say calculating Michaelis-Menten kinetics. Then on the next line, I'm going to write in Km equals 15.0. And so that's the Km value for the equation. Now notice I'm putting a pound sign, and then I'll say Km equals 15 micromolar. And Python will ignore anything after the pound sign on that line. Now I'm going to assign a Vmax, say Vmax equals 100.0. And then the comment Vmax equals 100.0 nanomoles per second. And then I'm going to write S, a capital S for substrate, S, CONC, S cons, equals 8.0. So there's our substrate concentration. Now I'm going to write another variable, velocity equals, and I'm going to put in an equation using the variables that we've already assigned. So the Michaelis-Menten equation, velocity equals Vmax times S cons divided by, and in parentheses, since it's a sum, I'll write Km plus S cons. All right. And I execute that cell. And notice that we don't have a value. Okay, we don't have the information there. But I do, we'll get to that in a minute. I want to point out a couple of things. First of all, the variable names don't contain spaces. That's essential. And it's important to be consistent. So if I put in a small v for Vmax here, in fact, I'll do it. If I put in small v for Vmax and I write that, it gives an error because Vmax is not defined. So let's go back to where it was.
So Paul, I want to say something very quickly, and I think that you probably said this, but in the Jupyter notebook, the way that he is running the cells so quickly is he's using a keyboard shortcut. He's pressing the Shift key and the Enter key at the same time. So you might have seen like this run button up here, but you can also press Shift and Enter at the same time, and that will execute the code that is in the cell.
Thanks, Jessica. All right. So now if we want to know what the actual calculated velocity is, we calculated it in the previous cell. I'm just going to write a print statement. And the print statement has this format. Just type in print in small and lowercase, and then a parentheses, and then the variable you want to know. So I say print velocity, and I hit Shift, Enter, and that gives me the answer, the numerical answer. Now, when we work with a variable, let's say we change, we do something to the variable. So I'm gonna do something in this cell. I'm gonna type in print, oh, no capitals there, print velocity. And now I'm gonna say velocity times 1000 and say print velocity again. When I do that, I printed the same exact value for velocity both times. That's because we didn't change the value of velocity. We multiplied that by a number, but we didn't change the value of the variable velocity. And so this is called something that's described as being immutable. The variable doesn't change unless you assign it some other value. So we could assign a different value. So I could go in here and I could say print velocity. And then I'm going to say velocity equals velocity times 60 or times 1000. And I say print velocity again. Whoops. I made an error. I put parentheses around that. It should have been print times velocity. And I'm guessing that some of you were typing very carefully exactly what I typed. You got the same error. So I'll wait a minute here. And so you can see that the number has changed. Because we actually changed the value of velocity, and you notice that we use the variable velocity, we multiply that by 1000, we assigned it to the same variable velocity. You usually don't want to do that. If you're going to change something, you probably want to give it a different name. So I'm going to do a couple things here. I'm going to change the value of velocity to the original value. All right. So I'm just going to say velocity equals velocity over 1000. So that's going to change it back to the original value. Now I'm going to make another variable, call it v per minute, because the other one was per second. And that's going to be equal to velocity times 60. Okay. Now if I say print velocity, and I'm also going to say print v per minute. And then I'll shift enter to run those cells. And you can see that the original velocity is here, is 34.78 and so on. And then the velocity per minute is 2086.95. So I know my first time through a workshop, I got to about this point and I made enough small errors in my typing that I was seeing problems and I was falling behind. So I'm gonna actually look at the clock for 60 seconds to give people a chance to catch up. And this is the time to remind you, if you have questions, you should take those to our TAs and they'll help you.
So maybe we
go
can
ahead.
discuss, yeah, sure. Maybe we can discuss one common error that we're seeing, which is on the cell where you have variable name equals variable value. So a lot of people have executed this as code. So Paul, can you talk about this cell a little bit?
Yeah, this cell is a markdown cell. And so I just wrote it this way so that you could see the format, the syntax we use for declaring a variable in Python and assigning a value to it. Is there anything else we should mention about that, Jessica?
So the important thing to notice about this cell is that if you see up on the top, it says markdown. So can you mouse over to where it says markdown? So markdown is a special type of cell that's used for giving information to people instead of giving information to computers. If you have this marked as code, when you try to execute it, it's going to give you an error. So for those of you who are seeing errors, we need to click markdown here instead of code. So go to that drop down that Paul is highlighting, click markdown, and then press shift and enter on that cell again, and the error should disappear.
All right, well, let's move on to assigning multiple variables at once. And this is actually pretty simple. In this cell here, we assign values for Km, Vmax, and substrate concentration. And so I'm going to do the same thing, but with multiple variables at once in a single statement. So, so I'll write here, I can assign multiple, all these variables at once. And notice I started that line with a pound sign, which means it's a comment, and Python ignores that. So I write Km, comma, Vmax, comma, S const. Actually, I'm going to change the names a little bit so that you'll know I'm using different ones. I'm going to use a lowercase v and Vmax, and I'm going to use a lowercase s and S const. Okay? And they're separated by commas. I'm going to say it equals to 15.0. 100.0, and I'm going to use a different value for substrate of 10, so we'll get a different answer, so you know it's a different answer. Now I go in and I use the equation, velocity equals Vmax times, Vmax times S const divided by, in parentheses, Km plus S const. Notice I use the lowercase s there. And on the next line, I'm going to write print velocity. Up, I have to use parentheses. Velocity. And I get the value for the velocity that way. So it's possible to assign multiple variables at once. And there are times when you want to do this. But one of the important things when writing code in Python in these cells, you want to be able to come back later and look back at it and understand why you did what you did, why you wrote it that way. So it's always good to comment on your code. And maybe the first time you do something, assigning one variable per line is a good idea. And then later, if you're doing it over and over, maybe you can do multiple times. So that's assigning multiple variables at once. The next thing I wanted to talk about were data types. In Python, there are multiple data types. The three I'll mention are string, which would be letters or numbers, but they're valued as letters, not as values. Integers, which would be whole numbers, and floats would be floating point numbers. So for example, if we look at the number for velocity, if I go in here and I want to find out the type for velocity, I just put in the phrase type, and then in parentheses, velocity, and it tells me it's a float. All right. Now, I could also put in, if I put in type and I put in a number 16, it would tell me it's an integer. And now I can also change types on data. So for example, let's say I'm going to call this, I'm going to declare a new variable, velocity string equals, and I'm using str, and I'll put velocity in parentheses. So what I'm doing is I'm converting velocity from in the variable velocity, the value has is a float, but in velocity string, I just changed it. So now if I type in type velocity string, it tells me it's a string. And one of the reasons we show you this is as we go through the workshop, it's entirely possible that you're going to get an error at some point that says that the type is not suitable for this kind of calculation. You're trying to do a calculation on a number and there's a string. It doesn't do it. It won't do a calculation on a string. So that may appear later. Now we're going to take a look at lists. And this is a very common data structure in Python. Use this all the time. Lists are sets of numbers that are within square brackets separated by commas. And Python is very particular about square brackets, parentheses, and curly brackets. And we'll be using all of those in different things today. So in this first cell, I want you to type along with me. So I'm going to make a comment first and say, the pound sign says it's going to be a comment. This is a list. Okay. And now I'm going to create a list of substrates. So I'm going to say S underscore CONCS equals, I'm going to make a list of substrate values here. It's a bit of a long list, 1.0, 2.0. I'm going to end up putting in 13 values. 3.0, 4.0, 6.0. It's important to enter each number separated by commas. 8.0, 10.0, 15.0, 20, oh, don't forget the comma, 20.0. And we got 4 or 5 more values to go here. 30.0, 50.0, 75.0, and 100.0. Notice also that conveniently, Python automatically creates the other square bracket. So if I hit square bracket again, it doesn't create a new square bracket. It just uses the one that it put there by default. So there's our list of substrate concentrations. And now this is a list, so it has a length. So I can determine the length of this list. So I'm going to say S underscore length equals, and then I use the function len, L-E-N, and then I put the name of the list in there. So the name of the list is S CONCS. And then I can put in print. And I'm going to stop for just a second and let you catch up. So at this point, you should have a list of 13 comma separated values in square brackets. You should have you should have a variable S underscore length to tell us the length. And notice this len function, this tells us the length of the list. And now I'm going to do something a little bit different here. In the print statement, I've got print, open in parentheses, and now I'm going to put in a single quote, this list contains, and that with a single quote, put in a comma, S, L-E-N-G-T-H. I don't need to put that in quotes because it's a variable. And then I'm going to put substrate concentrations. And so you should, at the end of this, you should get the feedback that as it appears on my screen. This list contains 13 substrate concentrations. And I'm going to ask people to put up your green check mark if that worked, and your red X if it didn't. Okay, I'm seeing a fair number of green check marks, a couple of thumbs up, which is just fine. All right, so Now,
Excuse me, Paul, sorry. I'm
go
getting
ahead,
a
sure.
request for you to scroll up and show the cell right there. Yes, thank you.
Okay. They want the type, the type parentheses velocity cell.
I believe so. The request I got was just a scroll up.
Okay.
So thanks.
All right, maybe I think a good practice I'll try to keep in mind is to keep the cell I'm working on toward the bottom of the screen so you can see the few cells above it in case you need to go back. So you might want to do an action on a particular element in a list, and we will actually do this in just a moment. And so we can actually address the elements in this list with integers. And the way we do this is, for example, if I want to print the first element, what I do is I say print, and then in parentheses, s underscore concs, open square bracket, a 0, close a square bracket, close a parentheses. And it printed the first element in the list. Now, Python starts counting with zeros. So 0 is the first element. The second element would be sconst 1 and so forth as you go down the list. Okay? And so you can actually use this in a calculation if you choose to do so. And so let's say I wanted to change the concentration from micromolar to nanomolar. So I could say S making sure I keep the same capital, uppercase, lowercase. And I'm going to say that, let's do this on element 12. I'm going to multiply that by 1,000 to change it from micromolar to nanomolar. And if I say print S, then you can see that element 12, which is 100 in this list, is actually 100,000 now when we did that multiplication. So you can address individual elements of a list at any time. One of the other ways we treat lists is something called slices. You might want to look at a part of a list. Okay, and I'm going to create a markdown cell here. So I go up, I clicked in the cell. I go up here and I say markdown. And so I'm going to put some text in there. And let's say I wanted to make a new list that was a subset of the original list. So it would be new list equals the original list. And then using square brackets, start and end. Okay, and so what that means is I'll need to identify the elements of the existing list that I want to add to the new list. And maybe the simplest way to do this is by example. So I'm going to say short list equals S so I want to take I have this list and I set the slice as 0:3. Okay, and so what's going to happen is that short list is going to take element 0, element 1, and element 2, but not element 3. So if I then say print short list, you'll see that element 0, which is 1.0, element 1, which is 2.0, and element 2, which is 3.0, are included in short list. Element 3 is not included. And so we would say the syntax for slicing here is we have the starting the starting index we want from the list and the final index we want from the list. And so we might write these in a variety of ways. And what I'm going to do is give you an exercise and give you 5 minutes to work on it. It's called Check Your Understanding. And so, I realize that I'm using a different, I think I used a capital S up here for, yeah, capital S constant. So I'm going to go in and change this, in fact. Now I'm changing this in a markdown cell. It doesn't affect any calculations, it just changes the way the notebook looks. So the question is, if I write the code slice 1 equals S underscore const 3 colon, what's that going to print up? And S underscore const colon 2, what's that going to print up? And I realized that I didn't explain what it would print up. So I want you to go in and try it and see what you get. And I'll give you 5 minutes to do that. Yeah, and when you get an answer, you can go ahead and put it in the chat window. Start to see a few answers pop up. Well, it looks like it's working for the people that are posting answers in the chat window, which is great. And so I think I'm not going to give 5 minutes for this. It appears to be working for most folks. So that's good news.
Maybe to get an idea, maybe we could use the check marks to know.
Yep. That's a good idea. So give us a green check mark if you got the answer. The answer showed up in chat. Actually, I'll run the code, and so you'll see the answer on my screen. So those are the answers you should be seeing, and seeing a lot of green check marks. Not seeing a lot of red X's, or red X's. So that's good. All right. So what we're going to do now is move forward to for loops. So far, looking at the stuff we're doing here, you're thinking, I could do this easily by hand. I could do this easily with a calculator. And that's true. But what we're going to see is the reason you use, or one reason to use computers is to have them do a task that need to be repeated many times. So doing a calculation once is fine, but doing a calculation 100 times by hand is not so fine. In fact, I remember, I'm not going to start talking about the good old days or the bad old days. Anyway, the standard format for a for loop is shown here. So we have for variable in list. Notice there's a colon. The colon is very important. It tells Python to indent the material that comes afterwards, and then it does all those things that are indented. And then it goes back and it goes through all the variables in the list. So what we're going to do here is what I want you to do is to go back up to the cell where you created your list of substrate concentrations. We're going to copy that. Okay, and bring that down. So there's our list of substrate concentrations. Now I'm going to create a for loop. So you type for space, I'm going to say number in S const, and it's followed by a colon. Now when I hit return, notice that it's indented. Python does this automatically in Jupyter Notebooks, and it tells it to do all of these calculations and then to go back and do the same thing until you've gone all the way through the list. So I'm just going to say velocity equals Vmax times number divided by Km plus number. Now we've already declared Vm and Kmax, so those are already in the system. And notice that instead of having sconst here, I had number because number is one of the elements in the sconst list. I'm going to come back and say print velocity. And then I hit Shift Enter. And so it went through that whole list and it calculated the velocity at every single one of those substrate concentrations. Now, This is nice, but it would be nicer if we had another list that contained the velocities we calculated. So if we actually took what we generated from this, instead of just printing it to the screen, we wrote it to, or we added it to a list. So if I go in here and I'm going to go back to this cell. I'm going to copy that code, put it in the cell below. But what I'm going to do is, instead of this print velocity, so I'm getting rid of the print velocity statement here. And I'm going to add something called the append function. And the way we use this, actually, I need to show you how this works. So I'm going to add a cell. Actually, you should watch this. So I'm in the cell that we just used for calculating velocities. So this is number 19 on my screen. I go up here and I click a plus sign that adds another cell below it. And I'm going to make this a markdown cell. So I go up here and I select markdown. And then I just type in here list name dot append new thing. So if you have a list, you can use this append command to add new things to the end of the list. Okay, so this is a markdown cell, so it's not going to do anything. This just shows you the syntax. And so what I'm going to do here is I'm going to create a list called velocities append velocity. All right. And now I'm going to come out of the loop. So I'm going back to the left margin. I'm going to say print velocities. And if you follow that, you should get the same error I got. This was intentional. And so the error is that this variable velocity has not been defined. We don't know what it is. So we just need to go and change this. In order to do this, we're going to have to create a new list called velocities. So I'm going to go in the next cell. And I'm going to say velocities equals open square bracket, close square bracket. So it's a list, but it's empty. There's nothing in it. I'm going to go to the previous cell, grab the rest of the code that I had in that cell. So we've got the line that has the the substrate concentrations in a list here. We've got the for loop, for number and s const, and then the two statements in the for loop, the velocity calculation, and then the appending the value of the velocity to the list velocities, and then finally a statement to print that list. So I'm going to grab those things, put them in there. And when I do that, it works. And velocity prints out as a list. And if we compare, it doesn't quite fit on the screen, but you can see that the end of this list equals to the end of the list we had before when we did the calculation. Only this time, the values we calculated are available now in a variable called velocities, which is a list of those 13 values. Now we're going to cover one more topic here. Let me give a quick check to the chat to see if there's anything that's really fuzzy about that. Okay, somebody said they got several lists. I'm not sure. Maybe one of the tutors can help you sort through that one. So another thing that we need to do are what are called logic statements. Quite often, you might want to use a piece of data if the concentration is at a certain level or not. So in this particular case, what we're going to do is, let's say we wanted to find out just the initial part of the Michaelis-Menten curve, where the substrate concentration is below the Km. We just want to plot that part. So we're going to go in and I'm going to declare two variables here, Km, comma, Vmax equals 15. No, I'm going to change those numbers so we get different answers, 20 and 200. All right. Then I'm going to declare another list of substrate concentrations. I'll call this one substrate underscore CONCS. And I'm going to put in, maybe just 5 or 6 values, so it isn't too long. So I'm going to put in 10.0, 20.0, 40.0, 80.0, and 100.0. So we have a list now with 5 elements in it. And now let's do a for loop. Oh, another thing we're going to do is we're going to declare an empty list. So we want to find out the velocity in the linear portion of the curve. So I'm going to say linear mm for the linear portion of the Michaelis-Menten curve equals open and close square brackets. So this is just an empty list. We're going to create a for loop. For number in this list, substrate CONCS. I put in a colon. That's going to tell Python to indent the next line, and it does. Now I'm going to use a logic statement. If number is less than km, I put a colon there. It indents again. To say V linear equals V max times number divided by, in parentheses, km plus number. And this is important. I'm going to say linear underscore mm dot append. So I'm going to add this to a list, and I'm going to add the V linear value to that list. All right, now I'm going to go back to the left margin, so I'm out of the loop. I'm going to say print linear mm. And when you do that, you should see 2 values here, because there were 2 substrate concentrations that were less than the Km. 10 and 20 are less than 25. So you should get 2 values here. And now we used this comparison less than. You can also use other values that are equal to, and notice it's 2 equal signs. If you're comparing 2 numbers to ask, are they equal to each other, you use 2 equal signs. Not equal to is a exclamation point with an equal sign. And greater than, less than, greater than or equal to, less than or equal to. And it's also possible to combine logical things with and, or, and not. And in light of the time, I think we're going to move on to the exercise. And we'll give you 10 minutes to work on this exercise. So here's a list containing some floating point numbers and some numbers that have been saved as strings. Copy this list exactly into your code, and then set up a for loop to go over each element of the list. If the element is a string, recast it as a float, and save all the numbers to a new list called number list. So you should probably go to this cell, hit the plus sign to add an empty cell beneath it. I should have put it there myself, and then go at it. And we'll give you 10 minutes to work on this. And this would be a great time. You can certainly put any questions you have in the chat. We'll be watching that. Jessica, any comments before we send them to the exercise?
No comments from me.
Okay, great. Great. All right. So it's 2:04. At 2:14, we'll take a look at your results.
Yes, so actually so we just had a request to scroll up a little bit. I'll comment a little bit on the exercise and maybe how you can approach it. So for this exercise, you're going to have to use several concepts that we just learned. So what might be helpful is to think about the problem, think about the information that you need to determine. And sometimes I find it helpful to even write down what I want to do or what my plan is, and then to start coding. And you can do it in pieces. You don't have to write everything at once. Paul, I am getting a question. I think that one person at least needs the is using Anaconda and needs the zip files. Would you mind sending those to the chat again?
Yep, will do. It'll take me just a minute to get that in place. Okay, that should be there in the chat now.
And if you have questions, feel free to send those questions to the chat or message TA.
All right. So what I'm going to do here is I'm just going to take this list right here, and I just typed it into an executable cell. And we're trying to create a new list called number list. So I'm going to say number list equals open bracket, close bracket, square brackets. Oh, okay. Yeah, Sarah put in a function that works. So I'm going to create a for loop then. So we'll use a for loop to go through the list, and then we'll use a logic statement to look at each element in the list. So for item in CONCLIST colon. So it indents automatically. And then we're going to say if type item is str. So this is a comparison operator. Another colon, it indents again. And we're just going to say item equals float item. So we're going to reassign that string to a float. Now I'm going to step out of the logic statement and add another statement to the for loop. Number list append item. And I'm going to step out of the for loop. I'm all the way back to the left margin and say print number list. So that's one possible solution. There are many. And that's what we end up with.
Can you please scroll up? It's at the bottom. It's hard to see.
Okay, can you see that now?
So just to ask, so is there something covering it when you say you can't see it, or is it just that it's at the bottom of the page?
It's at the bottom of the page.
Okay.
Okay.
And that makes it harder to see?
Yeah. Yeah.
Okay.
Okay.
So if it's in the middle, I can see now.
All right.
Part of the
Maybe-
type goes behind the bottom tab of Zoom with the mute and start video, etc.
Oh, okay. Okay, that explains it. Right, I'm looking at, yeah, I'm seeing some answers coming into the chat window, and the code looks like it will work. And it's interesting, not all code, 100 different people wrote this, we get slightly different versions for everybody. And in fact, one of my computer science professor friends at RIT tells me that he can spot plagiarism 100 miles away, because every coder has their own hand. They have the style that they write with and the way they lay things out, maybe the way they put in white space, the way they name variables, things like that. That's almost, it's very unique and very individual. Okay, any questions on this? We've got a couple minutes for questions here. Okay, somebody said I used equal instead of is to compare and it didn't work. Can you clarify why? Jessica, can you answer that question? I just know that that's what I'm supposed to do.
Yes, I can. So first question is, did you use equals or equals equals? Because equals equals is used to check if things are equal, but the equal sign is used for assigning variables. The second thing is that the is a keyword in Python, and equals equals is like a logic comparison, and what they do is very similar but not exactly the same. So is like equals equals is used to check if, like, say values are equal to one another. I think in this case equals equals might work.
Let's find
yeah.
out.
There are some times when equals equals and is are not the same, and I kind of think discussing it may go a little beyond the scope of what we've planned today. But in this case, they should be the same. You just have to make sure that you have equals equals instead of just one equal sign. And I think Charles also knows a lot about Python, so
I
maybe
think
he has
Python
something.
now actually throws up an error if you use is improperly.
Okay.
Right.
So,
Yeah, so
I would say don't use is unless you really know what you want to do with it.
Okay. I see a comment from another person saying the outcome they get was a list with just two numbers, 1.0 and 14.0. And if you look at the original list, those were the two strings. And so you converted those strings. Maybe, I bet what happened was you kept the line here that is number list dot append item. Maybe is that indented under item, or is that indented under the I of if? Because you wanted it indented under the I of if so that the for loop goes through it every time. If you keep it indented under item, under the I in item, then it only gets executed when the logic statement is being checked. Yeah, right. The equals equals does work. Pressy wrote, if I used if type number is not equal to float, and it worked. And in fact, maybe that's even a better approach because it's going to grab everything and convert it. I see an error from one person. Mine did not work. Error, str object is not callable, but it looks the same.
So, so I think, so if it says something is not callable, that means that you're using a variable that is a string or a floating point number and then putting parentheses at the end and maybe something inside of the parentheses. So callable is something that Python uses when it's talking about a function, which we've used some functions. Append is a function, so you'll notice that we have the word append and then parentheses, and in parentheses we have what we want to append. So append is a function, it does something for us. So whenever you're using those parentheses, you're usually using a function. If you're seeing something that says float is not callable, then you have like a variable that is not a function and you've got parentheses at the end of it, if that makes sense. So it's trying to call something that's a floating point number or something that's a string, and it can't do that because it's not a function.
There's an interesting question here from Natalie Lasada for the line number equals float number or item equals float numbers, which is what I'm showing. Is float an action in this case instead of just a type? And the answer is yes. In fact, what float is doing is it's converting whatever that item is to a float. You know, I see an example in the chat room of somebody who combined elements into a single thing, which is fine. All right, well, I think we've addressed the common common errors and challenges that are associated there. And I'm going to stop sharing my screen and turn things over to Jessica. And Jessica is going to take us into file parsing.